Hi again, everyone. Thank you so much for being still here. I'm grateful to see that you have survived the banquet, the morning session, and the lunch. And so, thanks to the detox beverage. And so in order to express my gratitude, I promise I will make this talk extremely short. I will jump right to the conclusion. Again. So, to conclude this talk, I have implemented an extension to the Knuth-Plass algorithm, which is able to address and handle similarity problems in paragraph justification. Thank you very much. I will take questions now. No. Just kidding. Okay, so please have a look at this paragraph and quickly tell me what's wrong in it. Well, there is a big clue inside. If you're unable to spot the problem with the clue, this is hopeless. Okay, so as you can see here, we have three occurrences of the same word at the end of three consecutive lines. So if you're interested in micro typography and high quality typography in general, this is considered a defect. Okay, so this is the actual. This is an emulation of the Knuth-Plass algorithm, which is done with my experimental typesetting algorithms platform that I demonstrated last year. But this is exactly how TUG would render this paragraph for a paragraph width of 201 points, and with the Latin modern Roman font at a 10-point design size. Okay, so this is the actual result of the TUG formatting. So why is this considered a defect? For different, actually two most important reasons for this. And mind you, this can happen at the end of lines, but the similar problem occurs at the beginning of lines as well, obviously. So the first problem with that kind of similarities is that the reader can lose the focus because the attention is disturbed by the fact that you see similarities either at the beginning or at the end of the line. Okay, so this is a disturbance, and the reader might be distracted when spotting similarities such as this ones. There is an even more important problem in that kind of situation, but even more important when the similarity occurs at the beginning of the lines, which is that you risk accidental line skipping, because when your eyes go from the end of a line to the beginning of the next, if two consecutive lines begin with the same sequence of characters, even short ones, like 2 or 3 characters, you may accidentally either omit a line because you think it's the line that you just read, or accidentally try to reread the same line, and so this is also a problem. And in fact, this problem has been known for a very long time. In humanities, there is a branch. Is Sarah here? No, not anymore. So I'm speaking out of control here. In the humanities, there is a branch which is called textual criticism, and basically this is a branch of humanities which studies the history and evolution of ancient texts. And it is known that similarity problems like these ones occurring at the beginning of lines have induced missing verses in Bibles, for instance, in the ancient times where monks were copying Bibles by hand. So if you find a similarity like this at the beginning of the line, then you end up with a copy of the Bible which is missing a number of verses. Okay, so this is also an important problem because of that, and it's been known for quite a long time. A word of terminology before we proceed. I'm talking about similarities here, and especially intentionally when I don't want to distinguish end of line or beginning of line similarities. I believe it's quite explicit, but there is also a number of potential terminological terms to use to describe those problems. In French, we have a very awkward expression which is saut du même au même, literally translated as jump from same to same. Trust me on this, even in French it sounds really awkward, so this is a typical case of pardon my French. I don't like this expression at all, but I've heard professional typographers use it, so it exists. In rhetorics, there is 2 nice terms, homeoarchy, which designate beginning of line problems, and homeotelutons, which designate end-of-line problems, but it means different things. Originally, it means the intentional using of similarities for poetic purposes or stuff like that. So this comes from the field of rhetoric initially. By sort of porosis between the domain, it has come amongst a number of professional typographers. It has come to designate accidental similarities occurring at the beginning or end of lines. I like those terms because I love to use complicated words. It allows me to brag in front of audiences and stuff like that. Well, anyway, otherwise you could also, and this is my own terminology, but I like it. I like to speak of word or character ladders. Because you might all know about hyphenation ladders, which is a much more widespread expression, and it's actually close to that. So, but I'm gonna keep on talking about similarities when the position doesn't matter. Okay, so I will not insult this audience by explaining to you what the Knuth-Plass is, but in order for you to understand where exactly I plug my extension in, I still need to recall the gist of it. Okay, so this is an example from the famous paragraph that you all know, which is used as an example, which was apparent on the previous slide, and this is the one actually used by Knuth in the founding paper on the justification algorithm that he wrote. Essentially, justifying a paragraph can be expressed from a theoretical computer science point of view as a so-called single pair shortest path problem inside a graph. Shortest path because for some definition of short, which actually could also be called the cheapest path, you want to find the best route available from one point to another. So in the graph, every node represents the end and the beginning of the end of a line and the beginning of the next one. So for instance, here you have a line which ends in beautiful, the next one starts with that, and from that you have a number of possibilities to create the next line, which will not necessarily end at the same position. Okay, so this is just an excerpt of such a graph. Why is it called single pair? Because the shortest path problem is a general problem. The particularity in this one, which is the reason why we call it single pair, is that we're only interested in finding the best route from a single origin, which is the beginning of the paragraph, to a single endpoint, which is obviously the end of the paragraph. So you only have one node here, and you only have one terminal node here. Okay, so this is the gist of this is the formal representation of the paragraph justification problem. On top of that, the Knuth-Plass, and this is the most important specificity of this algorithm, has a dynamic optimization technique coming from the field of dynamic programming. I will not go into the details, but the only thing that you need to understand is that this optimization is here to avoid the necessity for constructing the whole graph in memory. Okay, so you never have a global picture of all the possibilities available to you when you justify a paragraph, because the theoretical complexity of this is exponential. So for instance, if I remember correctly, because I did that a while ago, for the example paragraph that we use, if you try to typeset it at an average width, the number of possibilities is manageable, but if you were to double the size of the paragraph, you would end up, for that paragraph width, with something like 200,000 different ways of breaking the paragraph in theory. So this is a combinatorial explosion, and because of that, and even by today's standard, it's preferable to avoid constructing the graph in memory and only keep pieces of it at a single point in time. Okay, so that's the dynamic optimization, and the remote is not, yes, it's working. Okay, so what is the cost function? When we say finding the best route, what is the definition of best? So there are many as you want, actually, definition for what's best. In the Knuth-Plass algorithm, there is, I would have a tendency to classify the cost in two categories. The first one is what I call the local demerits. So as you most know probably, the demerits in questions are actually expressed in terms of penalties, which later on are translated into demerits. But this is what I call local demerits. So local demerits are penalties that are relevant when you consider a line excluding any kind of context. So the line just by itself. You extract the line from the paragraph, you just look at it, and you compute a cost for this line. So within the local demerits, what you have is the notion of badness, which is a penalty, which represents the fact that if you stretch or if you compress a line, then the cost will be higher compared to the natural spacing between the words. This is also the case where you apply an hyphenation penalty for lines ending with a dash, for instance, and so on. So that's the local demerits. And then there is another category of demerits in the Knuth-Plass, which I call global demerits, which are actually contextual ones. And those demerits are computed by looking at two adjacent lines, okay? So the Knuth-Plass, this is actually quite interesting because the Knuth-Plass is well known to consider a paragraph as a whole when you want to assess the quality of a paragraph. But in fact, the only way in which a paragraph as a whole is considered is only by looking at two consecutive lines, one with each other. It never does anything else than that. And so in the global demerits in question, the Knuth-Plass will augment the cost when two consecutive lines are hyphenated. Okay, this is with so-called double hyphen demerits. If there is an important imbalance between two lines in terms of scaling, then you apply adjacent demerits. So for instance, if a line is extremely compressed and the next one is expanded too much, then you will apply an additional cost. Okay? And finally, the final decision consists simply in minimizing the sum of the local demerits for every line and the global demerits, the contextual ones. Okay? So this is the gist of the Knuth-Plass. And what is of interest for us is the contextual demerits, because in the Knuth-Plass algorithm, there is already a way, there is already a place in which two consecutive lines are looked up and investigated. So the idea of this extension is actually extremely simple. What I do is introduce a new kind of global or contextual demerits, which for the time being I'm calling similar demerits. And the idea is extremely simple again. You just need to compare the beginnings and the ends of two consecutive lines. And if you find a similarity, you increase the cost by the value of the similar demerits in question. Okay? So the idea is actually extremely simple, and the infrastructure is almost already in there, because you just need to plug this extension at the place where the Knuth-Plass compares lines for adjacency problems or hyphenation ladder problems. Okay, so this is really almost all there is to it. Obviously, there's a special case for the final line, because the final line most of the time is not justified. So it would be nonsensical to try to figure out a similarity at the end of the final line and the previous one. So most of the time you don't need to do that, but it's still doable if the final line, in very rare cases, happens to still be justified as well. Okay. Implementation, this is what I do for the time being. So the nodes, okay, I have problems with this. Okay, if you look at this graph, as you can see, I've already represented the end of lines and the beginning of the next ones, okay? So in order to implement this sorry, what I do is augment the node structure representing the possible line endings in the graph by including the beginning of the line of the end of the previous line and the beginning of the next one. So this is a slight modification to the original data structure. And for the beginning of the lines, I'm eating the stuff that's at the beginning. For the end of the lines, I'm doing the same thing but backwards. So I'm eating the characters. I'm also discounting the kerns. And also, I'm stopping at the first discretionary or at the first glue, okay? You could do something else. You could do something slightly more complicated, but I think that it's really not worth it. So here's why. Discarding the kerns, avoid comparing stuff which will have probably little impact on the similarity perception from the human point of view, because kerns are extremely small spaces. And on top of that, if you have two consecutive characters which are identical and in all likelihood in the same font, then if there is a kern in between, it's going to be the same anyway. So you don't need to remember that, okay? Discarding glues. Well, that avoids to have to check for the vertical alignment, because the glues are elastic, so it could mess up the vertical alignment. But as long as you only compare stuff without elasticity, you don't even need to compare the vertical position or the position in the x-axis of the stuff that you're comparing. Okay. And why am I stopping at discretionaries? Because simply it avoids the additional complexity of deconstructing the discretionaries and looking what's inside. This is doable in theory. It would not necessarily be extremely complicated to do, but I don't think it's really worth it, at least for the time being. Okay? And finally, I think that even though this thing is actually quite simple, it's a typical case of who can do less can do more, because according to a professional typographer with whom I'm speaking currently, even similarities of 2 or 3 characters are enough to disturb the reader. Okay? So if you stop at that, you've already spotted an important problem, but if the similarity is actually longer, because you've detected a shorter one, you've already implicitly detected a longer one. Okay, so it's really not used to try to spot similarities of tens of characters, because that would be included in a similarity of 2 or 3. Okay. Right. So currently, what I have is I'm applying the similar demerits starting at similarities of at least two characters and maybe more. The calibration of the demerits is, for the time being, exactly the same as the other ones in tech, so it's between 0 and 10,000. Default value remains to be seen, but before going on with some experiments and statistical measurements that I did, I'm going to show you a quick demo of the result on one specific instance of this, and so this is the time when you can launch the video, please. So this video has been recorded with the platform that I showed you last year, ETAP. So as you can see, we start with the same paragraph that I've already shown you. So you have the word ladder at the end of the lines. And the similar demerits start at the value of 0, which means that we get the normal behavior of tech. And I'm going to gradually increase the demerits in question. And if you look at the word ladder down below on the right, there is a point at which, blam, yeah, there is one less. Okay, so it means that at that point, ETAP has found that it was too costly to have the 3 consecutive end words at the end of the lines, and it has pushed one. If you continue increasing the demerits, you get completely rid of the similarity, and this time, in fact, the words have moved within the paragraph. They're still quite close to each other, but it's much less disturbing. And the cost of this, if I remember correctly, the paragraph has had to be completely changed starting at line number 4. Okay, so this is a complete modification of the original thing. Obviously, I've selected an example which works well. And then I can hear your thoughts extremely loud. This guy is putting the cart before the horse again. Is it really worth doing something like this? Can we switch back on the slides, please? Okay, so you're absolutely right. Okay, the French typographer with whom I'm exchanging on this has a manual technique for addressing that kind of problem. And of course, you can do something manually if this is considered really too disturbing for you. The typical thing that you want to do is prevent the line from being broken here, for instance, and you would do the opposite on top of it for the similarity one line upwards, because if you don't do that, and you get rid of and you put an unbreakable space here, what you risk doing is transforming an homeoteluton into an homeoarchi. In other words, you risk transforming an end-of-line similarity into a beginning of line 1. Okay, so there is a manual way to avoid doing that. But the interesting question is, could we do this automatically, at least in a reasonable amount of situations, in order to avoid manual intervention? Okay, so the real question that should have been advertised before the experiments is actually twofold. First question, the pertinence of the similarity problem. Is it actually happening a sufficient number of times in order to really want to address the problem? And the second question is the efficacy of the extension which I'm proposing. In other words, is it able to effectively address the problem automatically in a sufficient number of situations? So in order to answer both of these questions, I did actually 2 orthogonal experiments, which basically boils down to typesetting one single paragraph at many different paragraph widths, okay? And that's the second one, typesetting many different paragraphs at a single width, okay? You could multiply the experiments again, but that is already that gives you already a number of individual cases, which is quite large. So this is the first experiment that I did. I took the first paragraph of the Grimm brothers Frog King text, and I've typeset it at a range of paragraph width that you can see here, ranging from 142 points, approximately 5 centimeters, to 569, approximately 20 centimeters, which gives you a total of 427 runs of the typesetting algorithms. And what you get is this curve. Apology for the colorblind people, I have no idea if this is readable or not. The purple curve here shows you the total number of possible layouts at every individual width, okay? Note that you cannot compute that with TEC, because TEC, being dynamically optimized, will never construct the complete graph in memory. But my platform has a version of the algorithm which does that, so I can know precisely how many actual solutions there is. And this is the purple curve. The green curve, which is below, gives you the number of paragraph solutions containing similarities, okay? So if you analyze that, there is, for starters, a number of things that are completely expected. The first one is the extremely chaotic shape of the curves. You all know that paragraph justification is an extremely unstable problem by nature. The simple fact of changing a paragraph width by 1 point can render a completely different solution than the previous one. Okay, so that explains the chaotic shape of the curves. The second thing, which is also to be expected, is that the curves are very close to each other for smaller paragraph widths. This is simply explained by the fact, again, it's very notorious that for very narrow paragraphs, you don't have a lot of possible solutions anyway. So it's not a surprise that with an extremely small number of solutions, whether there is a similarity or not is not going to change the difference between the two, okay? Slightly more interesting is when you look at the green curve, well, you notice that it's almost never zero, which means that solutions containing similarity problems are extremely frequent in paragraph formatting. Linguistically speaking, you have a lot of very small words in practically all languages, in French, in English, and everything. So it's not, and pronouns, determinants, and stuff like that. And they happen quite often in language, so it's not a surprise either. But at the same time, you see that the number of similarity-free layouts is also extremely important. In other words, if you take any point in this curve, the number of available layouts without similarities is comprised between the two curves. Okay? So it means that not only the similarity problem is frequent, but at the same time, there are similarity-free alternatives to choose from. And so obviously, the next natural question is, what is TEC going to do by default? Okay? So I did some computation on those statistics, and for this particular experiment, I found that in 4% of the cases, you cannot do without similarities. There are no solutions without similarities, so there is no choice. But I also found that in 21% of the cases, TEC will choose a solution with a similarity, at least one. This is a lot, okay? This is 1 paragraph out of 10. Okay, and for the second experiment, which I've yet to describe, this figure increases up to 26%. Okay, so conclusion for this experiment: 2 paragraphs out of 10 is a lot, because it means that a professional typographer like the French guy that I know with whom I'm working, when he typesets a novel or something like that, he would have to look manually at 2 paragraphs out of 10 and see whether it would be possible manually to fix the similarity problem. Okay? So the problem is worth addressing just because of that. So that answers the pertinence question. Okay, in terms of efficacy, I did another experiment, which is typesetting a cleaned up and filtered, yes, thanks, novel, the famous Moby Dick novel from Herman Melville, and that gave me 1,524 paragraphs, which I've typeset at a more or less random width, approximately 10 centimeters. If you add that to the first experiment, it gives you almost 2,000 individual runs. And what I did was also 3 different passes for every paragraph in question. 1 with the defaults from TEC. 1, which you see in the first column here, when I set the similar demerits to the maximum value. And a 3rd one, where not only the similar demerits are at the maximum value, but also I've set the adjacent demerits to 0. Mind you, this is nonsensical, but that gives you the worst possible situation, okay? So what I found is, if I do that, if I push the similar demerits to the maximum value, 48 to 50%, depending on the exact experiment, are corrected. It means that the algorithm will choose a similarity-free layout instead of a similarity non-free one, okay? There are also situations in which you have multiple similarities, and in that case, the algorithm will sometimes give you a new proposition which still contains similarities but less. And that's what I call improvement instead of just correction. And in that case, if you include the corrected paragraphs, then what you get is between 50 and 63% of the paragraphs which are automatically improved. If on top of that you disregard adjacency problems completely, that's column number 2, then you get between 53 and 66% of the paragraphs which are completely corrected. And if you look at improvement plus correction, that can raise up to 73% of the paragraphs which are going to be globally improved and automatically without manual intervention. Okay, so that's a nice result, even though I was putting the cart before the horse. So it means that automatic treatment of the similarities is possible. But please do not, again, this is really worth emphasizing on, those are extreme conditions. I'm not saying, please disregard adjacent demerits completely. This is not what I'm saying. The purpose of these experiments is only to give a feel of the leeway we have. In other words, when we have a similarity problem, is it possible to find alternatives automatically? But ultimately, whether a similarity-free solution will eventually look better than the one that TEC chose is ultimately in the eye of the typographer. Okay, so you need to look at that. But those experiments show you the leeway that you have. Okay, and so here is the real conclusion this time. The similarity handling extension that I'm proposing here is actually very simple and lightweight. Okay, it has a natural way of being plugged into the Knuth-Plass because everything is already here to compare adjacent lines. It is, in some sense, backward compatible with TEC because if you set similar demerits to 0, you end up with the original behavior of the Knuth-Plass. It's currently implemented in my experimental typesetting algorithms platform that I said, but it could be useful, obviously, in production engine because, as we saw, there is leeway to automatically fix the problem. Okay. In terms of experimentation, well, the stats speak for themselves, I'd say. Not only the problem is pertinent, because we saw that similarities are actually a frequent situation, but there is also a lot of, -1, thanks. I mean, overflow, as usual. Well, that I've said already. So just to finish that 30 seconds on the perspectives. the next step of these experiments is to study the trade-offs between similar demerits and the other aesthetic criteria. In how many situations is it worth finding an alternative layout? The French typographer to whom I shown the first example said to me it's stunning. So he actually prefers the solution that was found with my extension for multiple reasons, but I won't go into the details. So there is hope that automatic treatment is not only possible, but also gives you better result in the eye of a typographer. We could do much more, so much more than just fixating a constant value for similar demerits and using that. You could have different demerits for the beginning and for the end of lines. You could increase the penalty if the similarity is longer. There are many things that we can do. And in fact, I'm currently also talking with Hans and Michael Sundquist on the subject. So you all know what that means. It means that something might happen in LuaTech, who knows? Actually, Hans already did that, in a more or less different implementation a couple of years ago. But this was an incentive for them to start working again on this. And so perhaps we will come up with something which will be concretely implemented in LuaTech. We'll see. And that's all I have. Thank you. Sorry for the delay.
Okay, thank you for the talk. Are there any questions? I would say 2 minutes of questions, okay, and the rest you could ask them later.
Yeah, not really question, but rather comment. Yeah, Hans and Michael gave a talk at Bachotech this year where they showed, yeah, not on the similarity problem, but on other ways of improving the paragraph building. Also, if the paragraph contains some bit of embedded mass, lots of things that you can generalize, like having a series of whatever penalties, not just for the club and widow line for the first line, but also first, second, third line, or series of possible breakpoints. And I think they had some experiment where you have this badness function that goes into these buckets like very tight, loose, very loose, that you could do it in like more buckets. And so there are lots of options that you can do. I think there's probably coming a paper out of that. There's some slides on the Bachotech website, but I think lots of options there to do.
Plenty of things to do, increasing the number of adjacent categories as well. Well, never ends. And then the difficulty is finding the right balance between all the parameters, and maybe avoid putting on the user the mental load of having to work with thousands of different parameters to adjust at the same time.
Have you got an idea how expensive it is in computation time?
Computation time. So the fact that I'm doing the thing in the simplest possible way, which already addresses the vast majority of the cases, is an indication that the computation time is not very high, because you end up only comparing 2 short lists of character codes, for instance, and that's all. Also, Hans in LuaTech did a number of benchmarking experiments, and I know for a fact from him that the paragraph justification algorithm is not a bottleneck in LuaTech. So the impact on performance is extremely likely to be negligible.
Still another question there.
The same problem could happen in the middle of a paragraph. If the 3 ends would be under each other, visually it would be more disturbing, I think, than at the end. Is there something that can be said there?
So I don't think it would be more disturbing. Spotting a similarity in the middle of a line, I think it's less disturbing than at the beginnings or at ends. But a related problem is that if you have similarities at the middle of the line, I would rather say that you need to address the reverse problem instead of the similarity itself. And reverse is also on my to-do list, but it's just going to take a bit longer. But that would introduce a river, which I think is more important to fix.
Are there any questions from the internet? I guess not. Then thank you for
Okay,
your
thank
talk.
you very much.